Okay, so this is me testing some cell balance via energy transfer circuits that I got from DeliGreen, I think is the name of the company. A normal cell balancing that's normally used widely throughout the battery industry is a resistor transistor bleeding method where it would take the energy in these top cells here and bleed them off until it was closer to this, until they lined up with this bottom one. The energy transfer method transfers the energy from the higher ones into the lower ones instead of bleeding it off. There's, of course, not 100% conversion efficiency. There's a little bit of losses, but it's more energy. You're not just throwing it all away as heat in resistors. You are converting the bulk of it, like 90+%. And you can see here how they were deliberately initially out of balance for these different voltages. Then over time, it slowly brings them in. The way this particular one works is that the higher the voltage difference, the faster or greater the balancing effect that it tries to do, up to, of course, its limits, which is kind of the direction you want. So the closer they are to each other, the more that the balancer can kind of ease up and not worry about it too much, doesn't have to try to match. And then the worse things are, the more important it is that it tries harder to try to fix it. Over here, you can see this is within like a millivolt of each other. The spec on the balancer is actually 10 millivolts to 30 millivolts, depending upon your application and details and context. But just like if you buy a bunch of cells, battery cells, and then you test them to build a matched pack that are all similar to each other, you can do the same thing, the same concept from circuits like this. And you can take the ones and then sort out the ones that are very closely, like this, for your more sensitive applications. And the other ones are still fine, like those batteries might still be fine. They're just not as matched. And the other ones that are only 10 or 20 or 30 millivolts, those aren't as matched. So that would be for some other less sensitive application. You could still use them for those. And this is just logging that. The other thing here to show real quick is that if I look at the total pack voltage over time, you actually see that it goes up. We're not creating energy from nowhere. In fact, the little balancers are, like we said, they're not 100% efficient, so they are consuming some amount of energy in that process. But what's happening is that the increase of this one, it takes this bottom one to go from low to high, you get more voltage increase than this has voltage decrease, because the amount of energy it takes to get this one up versus the amount of energy taken from this one is not linear. It's not the same. There's a little bit of a slope there. And that's why on that other graph, you see the voltage over time going up a little bit for the whole 4 cells. Compared to when we look at the individual cell levels, we just see them coming together and merging within a millivolt now. And it did take, you can see it took about an hour and a half or so